In the previous video, we have learned about electrolysis of molten solutions. In this video, we'll be learning about electrolysis of aqueous solutions and how electrolysis of aqueous solutions is different from electrolysis of molten solutions. So the key difference is when you take an aqueous solution, what you do is you take an ionic compound, add it to water, then it becomes an aqueous solution. So in aqueous solution, you have ions of water which are H plus and OH minus ions. That means apart from the ions of the ionic solid, you also have ions of water which are H plus and OH minus. So let us see what happens at the cathode. At cathode, you have H plus ions and the metal cations. So these H plus and metal cations compete to get discharged at the cathode. At anode, you have OH minus ions and non-metal anions. So these OH minus ions and the non-metal ions, they compete with each other to get discharged at the anode. So let us see which ions gets discharged at the cathode. So if you have any aqueous solution for electrolysis, let us see which ion gets discharged at the cathode. So at the cathode, do remember that the least reactive gets discharged at the cathode. Okay, so the least reactive cation wins. That means the least reactive cation gets discharged at the cathode. So this is our reactivity series. Now, the elements which are above hydrogen, if you see elements which are above hydrogen, they are more reactive than hydrogen, right? So if you find any elements which are above hydrogen, or you can say if you find any ion which are above hydrogen, that so hydrogen gets discharged in the place of those ions. If metal cation, example Na plus, K plus, Mg plus, or any metal ion which is above hydrogen in the reactivity series, it stays in the solution and H plus ions formed from the water gets discharged. So what we should understand here is if there is any metal ion, any metal cation which is above hydrogen in the reactivity series, that stays in the solution and hydrogen gets discharged because hydrogen is less reactive than them. Now, below hydrogen, if any metal cation, let it be copper, silver, or gold, so these are below the hydrogen in the reactivity series. If you find these ions in the aqueous solution, they will get discharged. These metals will get discharged at the cathode and hydrogen stays in the solution. H plus ion stays in the solution. So the golden rule is that if you see any metal cation like copper, silver, and gold. So if you see metal cations like copper, silver, and gold, so straight away you should understand that these will get discharged at the cathode. If in the question you don't find any of these three cations, you find any other metal cation, so in that case, hydrogen gets discharged. That is the straight rule. You can say this is the golden rule, which makes it easier. Now, let us understand which ion gets discharged at the anode, right? So at anode, things are a little different. So anions present at anode. So anions can be halides like chlorine, bromine, and iodine. So if you find any of these anions in the question, like chlorine, bromine, or iodine, then you have to check for the concentration. So if they are concentrated, that means if the solution is concentrated, then hydrogen gas is deposited at the anode. which halogen gas? It can be Cl2 gas, it can be Br2 gas, or it can be iodine gas. So if the solution is concentrated, halogen gas is deposited at the anode. And if the solution is dilute, right? So if you have chlorine, bromine, or iodine ions present in the aqueous solution, and if the solution is dilute, in that case, at the anode, O2 gas is evolved. And if you don't have any of these ions present in the solution, if you don't have fluorine, chlorine, or bromine ions in the aqueous solution, then the half equation, or you can say, then O2 gas is evolved at anode. So what happens if what happens if fluorine, bromine, and iodine are not present? See, at anode, ions which are most reactive gets deposited. And in the periodic table, chlorine, bromine, and iodine, chlorine, bromine, and iodine, these are the ions which are most reactive in the periodic table. Now, if you don't find these, then the next reactive ion is OH minus, right? So if you don't find any of these ions in the aqueous solution, then you have to understand that OH minus gets discharged at the anode, and while OH minus gets discharged, O2 is evolved. Okay, oxygen is evolved at the anode. So in two cases, oxygen is evolved at the anode. First case is if there are no halide ions present in the aqueous solution. Second case is that if there are ions like fluorine, if there are ions like chlorine, bromine, and iodine, but the solution is dilute. So in that case, again, O2 gas is evolved at the anode, right? I hope things are clear here. If you have any kind of doubt, if this thing is still not clear, if you have any doubts, you can comment down in the comment section. I will solve your doubts. Now let us take an example of NaCl, aqueous, concentrated aqueous NaCl. You have to see this very carefully whether it is concentrated or dilute. Okay, so concentrated aqueous NaCl. So when you get concentrated aqueous NaCl, what are the ions which are at cathode and what are the ions which are at anode? At cathode, you'll find ions like Na plus and H+. At anode, you'll find ions which are Al minus and OH minus. Okay, so at cathode, you'll find ions like Na plus and H plus. At anode, you'll find ions like Cl minus and OH minus, right? So, as we have learned in the previous slide, that at the cathode, least reactive gets disassociated or discharged. Least reactive gets discharged. So, out of these both, which is least reactive? Of course, H plus is least reactive. So H plus gets discharged at the cathode. Now let us look into anode. At anode, before going to anode, you have to see whether the solution is concentrated or aqueous. Okay, if it is concentrated solution, then you have to see which of these ions is more reactive. Which is more reactive? Cl minus. Cl minus is present and it is concentrated. So Cl will get discharged. So any of the ions which are chlorine, bromine, and iodine, if these are present and the solution is concentrated, in that case, you get halogen gas. Okay. So because you have chlorine here and the solution is concentrated aqueous solution, so in that case, the halogen gets discharged. So these are the half equation of hydrogen and chlorine. So this hydrogen is, if hydrogen gas is evolved at cathode and the chlorine gas is evolved as at anode. And NaOH, Na plus and OH minus, they stay in the solution. So NaOH is formed. This electrolysis is also this electrolysis of concentrated NaCl is also called as electrolysis of brine solution. Now let us get into the electrolysis of dilute sulfuric acid. Dilute sulfuric acid, right? So what are the ions present? H plus, SO4 minus, and OH minus. Is there any other ion with ion which is present here? No. Okay. So which gets deposited at the cathode? Yes, of course, it's H plus. H plus is the only cation present. So H plus gets, you can say it gets discharged at the cathode. H plus gets discharged at the cathode. Now at anode, this is a dilute solution, right? And is it having fluorine? Is it having chlorine, bromine, or iodine? No, it doesn't have chlorine, bromine, or iodine. It is having sulfate ion SO4 2 minus ion, and it has OH minus R. So straight away, OH minus gets discharged, and O2 gas, due to which O2 gas is evolved at the anode. So these are the two half reactions which happen at cathode and the anode. Sometimes in the questions, the test for gas is also asked with with electrolysis of a solution. It is all these tests are also asked test for the gases. So test for hydrogen gas is the hydrogen gas burns with pop sound, right? And the test for oxygen gas is that it relights the glowing spring. If you take a glowing split, you take near the oxygen gas, it relights. So these are the different half ionic equations of different aqueous solution for concentrated NaCl, dilute NaCl. If you observe here, for concentrated NaCl, at anode you are getting Cl2, and in the dilute solution, at anode you are getting oxygen gas. So there are also other different reactions present here, half equations present here. You can take a screenshot of this and screenshot of this table as well. This table is very, very, very useful because this table will help you write the products of electrolysis of the aqueous solutions. Now it is past paper time. So we have two questions here. Let us solve them quickly. The first question, this appeared in your May June 2023. The question says the electrolysis of concentrated aqueous potassium bromide using graphite electrode spawns hydrogen at cathode and bromine at the anode. The electrolyte becomes aqueous potassium hydroxide. So let us first understand the question. In the question, it is saying electrolysis of concentrated aqueous sodium bromide. So this is our reactant, or this is our electrolyte basically, aqueous potassium bromide. We are using graphite electrodes. So when we are using graphite electrode, hydrogen is formed at the cathode and bromine is formed at the anode. In the exam, while reading the question, you have to make a habit of underlining the important points. So these are the important points in the question. So it says the electrolyte becomes aqueous potassium hydroxide. Right. So let us see what is being asked in the questions. State what is meant by the term electrolysis. So what is electrolysis? Electrolysis is a chemical reaction in which electricity is used to split ionic compounds. Or you can say electrolysis is a chemical reaction in which electricity is used to separate the ions in a aqueous solution or in a molten solution. Or you can say separate ions in a aqueous or molten solution. State why graphite is suitable for use as an electrode. See, graphite is inert. It does not involve in the reaction. So that is why we are using graphite as an electrode, because it is inert and it does not involve in the reaction. Does not involve in the reaction. Write down the half ionic equation for formation of hydrogen at cathode. So at cathode, what happens at cathode? Oxidation or reduction is reduction. So what happens in reduction? In reduction, electrons are gained, right? So 2H plus 2 electrons give rise to H2 gas. This is the half ionic equation. Yeah, ionic equation for the formation of hydrogen at cathode. State the name for the product formed when electricity is passed through dilute. Okay, dilute aqueous potassium bromide. Remember, dilute aqueous potassium bromide. Okay, the moment you say dilute, at anode, O2 is evolved. Why? Look at the previous slide or go back to the video and check why you should write O2 at why is O2 obtained at anode when you see dilute solution. So at anode O2 is evolved, and at cathode least reactive is deposited. Least reactive is discharged, right? So when you have aqueous solution at the cathode, you have two ions, right? At the cathode, you have two ions. Which are they? Yes, the H plus ion and the K plus ion. Which is least reactive here? Which is least reactive? Yes, H plus is least reactive. So what is obtained at cathode? H2 gas. Simple, right? See, if you know the concept, it is very simple. But if you don't know this concept, you tend to write wrong answers. Question number 2. A student electrolyzed aqueous copper sulfate using graphite inert electrodes. So, what is the solution here? Aqueous solution? Aqueous copper sulfate. And we are using graphite electrodes. Name the product formed at the cathode and explain why it forms rather than the hydrogen gas. So here you have copper, right? So at the cathode, because it is aqueous solution, at the cathode, what are the two ions which are present, which compete with each other? Cu plus 2. Why am I writing plus 2 here? Because you see 2 in the bracket, so I am writing Cu plus 2 and H plus. Which is least reactive between copper and hydrogen? Copper, of course. So copper gets deposited at the cathode. Why? Because copper is less reactive than the hydrogen gas. You can write hydrogen gas or H2. Like, you can completely write hydrogen gas or you can write H2. Name the product formed at the anode and write down the half ionic equation. Okay, so here aqueous solution is given. It is not written whether it is concentrated or whether it is dilute. It is only given aqueous solution. Fine. So in what do we have here? Sulfate. So sulfate, SO4 2 minus, right? So this is anode, right? So at anode, at anode, we have SO4 minus ion and what else? OH minus. Yes. So SO4 minus and OH minus. So out of this both, which is more reactive, or if you follow the flow chart which I've explained in the previous slide, in that I've explaining that if there is any other ion other than chlorine, bromine, and iodine, you straight away have to choose OH minus, because OH minus gets discharged at the anode if chlorine, bromine, iodine are not present. So when OH gets discharged, what is the equation? You have to remember this equation, okay? This is very important equation. It is a little big when compared to the other equations, so you have to remember it. You have to remember this equation. 4OH minus gives O2 plus 2H2O plus 4 electron. Okay? Do you remember this? Do remember this equation, right? So, do remember this equation, and we are done with these two questions. We have solved these two questions because so that you can get an idea how to solve the questions related aqueous solutions, electrolysis of aqueous solutions. In the next video, we'll be having a detailed past paper session. We'll be discussing at least 5 to 6 questions which appeared in your previous past papers, which are related to electrolysis. So stay tuned. Goodbye.